Hello friends, today we discuss topic bivariate linear regression. So first definition of linear regression. In statistics, linear regression is a linear approach to modeling the relationship between the dependent variable and one or more independent variable. So simple linear regression, or we can say bivariate linear regression, its definition is: a simple linear regression is a linear equation describing the relationship between one dependent variable and one independent variable. So methods to find linear regression equation y on x. We call this method as least square method. So consider simple linear regression equation, simple linear equation of the type y is equal to a plus bx. Suppose this is equation number 1, where x is dependent variable, x is independent variable, y is dependent variable, a is y-intercept and b is slope of the line. Then first we take summation of this equation 1, taking summation of equation 1, we get summation y is equal to summation a plus summation bx. Here a and b are constant, so we can take this constant outside the summation sign. We get summation y is a into summation 1 plus b into summation x, as summation 1 means I from 1 to n, this is equal to 1 plus 1 plus 1 n times, this is n times. So value of this is 1, means summation 1 is n, value of this is n, so summation 1 is n. So summation y is n into a, because summation 1 is n, so na plus b summation x. Consider this as equation number 2. Then again we take equation number 1. First we multiply equation number 1 by x, and then if we take summation, we get multiply equation number 1 by x, and then take summation. So we get, first we multiply by x, so xy is equal to ax plus bx square, and if we multiply by if we take summation, then we get summation xy is, here a is constant, take outside the summation sign, so summation x, plus here b is also constant, we can take this b outside the summation sign, we get summation x square. So summation xy is a summation x plus b summation x square. So this is suppose equation number 3. Equation number 2 and 3 are called as normal equations. Equation number 2 and 3 are called normal equations. So here we have to find values of a and b and regression equation y on x. So for this, first we take equation number 2. From equation number 2 we get from equation number 2, we get summation y is na plus b summation x. If we divide this equation by n, we get divide this equation by n, we get summation y upon n is equal to na upon n plus b summation x upon n. So we know that summation y upon n is nothing but y bar. This n is cancelled with this n, so here a plus b. Here summation x upon n is x bar, so we get y bar is equal to a plus b x bar, or we can write a is equal to y bar minus bx bar. This is value of a. Suppose over this is equation number 4. Then put value of a is equal to y bar minus bx bar in our equation number 1, we get, then we get our equation number 1 is y is equal to a plus bx. If we put a is equal to y bar minus b x bar here, we get y is equal to y bar minus b x bar, y bar minus b x bar plus b x. If we simplify this, we get y minus y bar is equal to minus b x bar plus bx, or we can write this as y minus y bar is equal to b in bracket x minus x bar. So this is regression equation y on x, where this is regression equation y on x, so we use symbol b as byx. So y minus y bar is equal to byx. This is just a notation symbol, x minus x bar is regression equation y on x. Then we find regression coefficient b, or you can say byx. For this, consider equation 2, which is y summation y is equal to na plus b summation x, and equation 3, which is, see here, equation 3 is summation xy is equal to a summation x plus b summation x square. So here we multiply, here we have to cancel this constant a. So for this we multiply equation number this 2 by summation x and this 3 by n, and then we cancel this a. So multiply equation 2 by summation x and equation 3 by n, and subtract equation 3 from equation number 2, we get, so this is our equation number 3. If we multiply this equation 3 by n, we get n summation xy is equal to na summation x plus nb summation x square. This is our equation number 2. If we multiply this equation by summation x, we get summation x into summation y is equal to na summation x plus b summation x into summation x is summation x bracket square, and we have to subtract this equation number 3 from this equation number 2. So if we subtract this, we get, suppose this is minus minus minus, we have to subtract this equation, so summation x y, we subtract equation number 3, this is equation number 3 and this is equation number 2. So subtract this equation from this equation, we get n into summation xy minus summation x into summation y is equal to, this na summation x is cancelled with this na summation x. So here nb summation x square minus b summation x bracket square. So if we divide throughout by n square, we get, divide both sides by n square, then we get n summation xy upon n square minus summation x into summation y upon n square is equal to nb summation x square upon n square minus b summation x bracket square upon n square. So see here, this one n is cancelled with this n, and here remaining term is summation xy upon n minus, here summation x upon this one n is x bar, then summation y upon remaining n is y bar. So summation xy upon n minus x bar into y bar is equal to, here this one n is cancelled with this one n, and remaining term is summation b summation x square upon n minus b, here summation x bracket square upon n square, we can write this as summation x upon n bracket square, and summation x upon n is nothing but x bar, means x bar bracket square. So b in bracket x bar bracket square. So summation xy upon n minus x bar into y bar, take this b outside the bracket, we get summation x square upon n minus x bar bracket square, and here we have to find value of b. So value of b is nothing but this summation xy upon n minus x bar into y bar upon this quantity summation x square upon n minus x bar square, and we know that summation xy upon n minus x bar into y bar is nothing but covariance of xy, and the summation x square upon n minus x bar square is nothing but standard deviation of x bracket square. So this is equal to covariance of xy upon sigma x square. So this is regression coefficient of y on x. So we give symbol byx is nothing but covariance of xy upon standard deviation of x square. So this is regression coefficient byx. Then we take one problem. Suppose this problem is given. From the following data, find regression equation y on x and also find y when x is equal to 2.5. Values of x and values of y are given. So here we know that formula to find regression equation y on x is y minus y bar is equal to byx into x minus x bar, where byx is nothing but summation xy upon n minus x bar into y bar upon summation x square upon n minus x bar square. So this is formula to find byx. So here we require x bar, y bar, summation xy and summation x square. So for this, here we write x, y, then x square, x into y. So here values of x are 1, 2, 3, 4, 5. Values of y are 10, 20, 30, 40, 50. Then x square, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25. X into y, 1 into 10. 1 into 10 is 10, 2 into 20 is 40, 3 into 30 is 90, 4 into 40 is 160 and 5 into 50 is 250. So here we find total of this means summation x is 1 plus 2 plus 3 plus 4 plus 5. So 5 plus 1 is 5 plus 4 is 9, 9 plus 3 plus 2 plus, if we add this we get 15. Then summation y is, if we add this we get 150. Summation x square, if we add these quantities we get 55. And summation xy, if we add these quantities we get 550. You can check these calculations. So these are our totals. Here we require x bar and y bar. So first we calculate x bar. X bar is summation x upon n. So here summation x is 15. How many pairs of observations are given? 1, 2, 3, 4 and 5. 5 pairs of observations are given. So value of n is 5. So 15 upon 5 is 3. So our value of x bar is 3. Then y bar is summation y upon n. So here summation y is 50 and value of n is 5. So 50 upon 5, which is 10. Sorry, here y bar is 150. So 150 upon 5. So 150 upon 5, if we calculate, then we get 30. So y bar is 30. Then we put all these values here. So byx is summation xy upon n. Here summation xy is 550. Value of n is 5 minus x bar is 3 and y bar is 30 upon summation x square, which is 55 value of n is 5 minus x bar square. X bar is 3, so 3 square is 9. So 550 upon 5, if we divide 550 by 5, we get 110 minus this 90 upon 55 upon 5, which is 11 minus 9. So this is equal to 20 upon 2, means 10. 20 upon 2, which is equal to 10. Then use our this formula, y minus y bar is byx into x minus x bar. So here y minus y bar is 30, byx is 10 into x minus x bar is 3. So y minus 30 is equal to 10x minus 30. So y is equal to 10x minus 30 plus this 30, means y is equal to 10x. This is your regression equation y on x. They also ask sub question, find y when x equal to 2.5. So when x equal to 2.5, then we put x equal to 2.5 in y is equal to 10x, we get y is equal to 10 into 2.5. So if we calculate this, we get y is 25. This is our final answer.